All right, class, welcome back to combinations or combinatorics in Algebra 2. Chosen today for you example number 1 on page 378. We'll look at it first, and then I've got about 4 more examples for us to go through. Combinations or combinatorics are reserved for where order does not matter when we're drawing from something. So we're going to be drawing from a 52 card deck today. Order does not matter, making the combinations very useful. So, example number 1, there are 2 different particular problems in there. A says, how many different 5-card hands out of a deck of 52 cards are possible? So we're going to deal with it as a combination. There are 52 cards in a deck, and we are drawing out 5-card hands. So, by definition, this says that we're looking at n factorial, or 52 factorial, divided by 52 minus 5 factorial, that's n minus r, times r factorial, or 5 factorial. So by hand, we're going to work this out. It would be 52 factorial over 52 minus 5 is 47 factorial times 5 factorial. There's a shortcut. Instead of doing 52 times 51 times 50 all the way down to 1, we can just go down to the largest factorial that we're trying to divide by. So that gives us 52 times 51 times 50 times 49 times 48. Now I'm going to stop at 47 factorial. It itself is going to be a factor because they're held together with multiplication, times 47 factorial times 5 factorial. 47's cancel, 47 factorials cancel. We're left with 52 times 51 times 50 times 49 times 48 divided by 5 factorial is 5 times 4 times 3 times 2 times 1, or 120. So we are taking the values 3, 1, 1, 8, 7, 5, 2, 0, 0, and we're dividing that by 120, leaving a total of 2,598,960 possible 5-card hands out of a deck of cards. So as people are playing professionally cards, just realize the odds many times that they're up against. All right. B says, how many 5-card hands of all the same color can you come up with? Well, there are 2 different colors in a deck of cards. There are the black colors and the red colors, and we're trying to draw out all the same color. Okay, we're trying to draw out all the same color. Now, I need to figure out how many hands there are possible. This is going to result in a 2, by the way, 2 factorial over 2 minus 1 factorial times 1 factorial, or just 2. So this is going to be 2 times, and then out of one color, this takes care of both colors. This is out of one color now. It's a combination of n being 26 and r being our 5. This is going to be 26 factorial over 26 minus 5, which is 21 factorial, times 5 factorial. That is 26 times 25 times 24 times 23 times 22 times 21 factorial over 21 factorial times 5 factorial. 21 factorials cancel, and 26 times 25 times 24 times 23 times 22, again divided by 120, or 5 factorial, is 131,560 possible combinations or delts of hand dealt of cards. All right, I've got 4 more examples we're going to try and get through in the same video. All right, how many hands consist of entirely clubs, or entirely hearts, or entirely spades, whatever your choice is? Again, these are just some extra examples. All right, well, let's talk about how many clubs there are in a deck, or how many spades are there in a deck. And we can treat this as a combination as well. 13 is our n to draw from. Okay, there are 13 clubs in this particular case, and we're trying to draw 5-card hands. Now, we can go through the same process. I'm going to show you how to do it on your calculator this time. if you will type in the number 13 on your work screen, then go to Math, arrow over to PRB. This is going to be the probability and statistics area of your calculator. Use the drop down, choose number 3, which says N, capital C, R. When you choose number 3, 3 should actually pop up on your screen, and N, capital C, and R should pop up next, and place for you to type in our 5, or choosing 5 card hands. When you press enter, it should come up with 1,287 hands. And these would be great for you guys to practice and go through on your calculator. Make sure that you're good with that. All right, next question says, how many 4 of a kind, for example, queens, and 1 other card hands are there actually available? I've circled the word and lots of times is going to imply multiplication for us, all right? Now, if we think back about our card suits, there are 4 suits, but there are 13 cards per suit. So if we want 4 of a kind, we need to stick with, we'll either have like 4 2s, 4 3s, 4 4s, 4 5s, even 4 face cards like 4 jacks or 4 kings or 4 queens or even 4 aces. So we're looking at the first combination. There are 13 groups of 4, so we're pulling out of 13. We want to pull a group of 4. With that said, there are 48 more cards to choose from once we get our group of 4 out. And our combination with an N of 13 and R is 1, and then multiplying it times N of 48, because this is how many cards we have left over to draw 1 more card from. So it's going to have to be an AND scenario. It should equal to 13 times 48, which is 624 hands. So as you can see, the more complicated the hand is, the less number there are. And remember, this is out of 2,598,960. Okay, so last couple here. I think I'll do the one at the bottom first. How many hands of 2 kings and 3 queens? So another multiplication because we're trying to put 2 groups together. All right. So as far as combinatorics, we want 2 out of the 4 kings available in a deck of cards, and we want 3 out of the 4 queens available. And when you do the combinations on your calculator, you're going to get 6 times 4, or 24 hands. And again, it's getting less and less and less possibility or probability of actually drawing these hands. All right, so I've left this last one for the end, just because it's a little trickier. I'm going to erase the one below now about 2 kings and 3 queens, so that we have plenty of room. All right, how many hands of at least? Okay, at most, typically will indicate subtraction. At least, typically will indicate addition. So I either want a hand with 2 kings, or 3 would be fine because that would be at least 2, or even 4, and there are no more than 4. So we're looking at hands of either 2 or 3 or 4. All right, so combinatorics. If I get 2 kings out of the 4, then I need 3 more cards. If I get 3 kings, which is at least 2, then I'm going to need 2 more cards. And if I draw all 4 kings, okay, I'm still going to need 1 more card to make up my 5 card hand. So this is exactly 2, exactly 3, exactly 4. These combinations, when you multiply them together, result in 103,776. Next, getting 3 3 kings is a lot harder. 4,512. What if we get all 4 kings? Four of a kind and then 1 other card. Well, there are only 48 options for that. 48 hands or combinations. But if we want at least 2, then it's all of these summed together or added together, which is 108,336 possible hands or combinations. All right, hope you enjoyed combinatorics.